just repeat it again. So today we are discussing about midpoint theorem. So what it says is, if there is a triangle ABC and D and E are the midpoints of the sides AB and AC, then if we join this DE, this will be parallel to BC and it will be half of BC. This is what we need to prove, and it is given that AD is equal to DB and AE is equals to EC. This is given. So let us see how do we do it. What I'm doing is I am extending this DE. Fine, I am extending this DE to a point F such that DE is equals to EF. Okay. So extend DE to F such that DE is equals to EF. This is what I have done. Now I am joining CE. Sorry, I am joining CF. Fine. So we have joined CF. Okay. Now, since AD is equals to DB and AE is equals to EC, right? This is given to me. Okay. So then if you see the triangles ADE and the triangle CEF, if I see these two triangles ADE and CEF, I can see that these two sides are equal, right? And these two sides are equal because it is given, and these two angles are equal because these are vertically opposite angles. So these two triangles are congruent by SS property, right? So DE is equals to EF. This is our construction, and AE is equals to EC is given to us, and angle AED is equals to angle CEF, since these are vertically opposite angles. So then we can say that these two triangles are congruent, right? So if these two triangles are congruent, then I can claim that this angle DAE, should be equal to angle ECF, and also I can say that DA must be equal to CF, right? So this angle must be equal to this one, and DA must be equal to CF. Okay. So now, since these two angles are equal, right, I can say that DA is parallel to CF because these alternate angles are equal. So by this thing, I can say that DA is parallel to CF. Fine. So this means that BD is also parallel to CF, right? Because if DA is parallel to CF, then BD is also parallel to CF because BDA is a straight line, right? So this line is parallel to CF, right? And also CF is equals to BD, right? So since CF is equals to BD and BD is parallel to CF, from these two conditions I can say that BD CF BD FC must be a parallelogram, right? Because if in any quadrilateral, if one pair of opposite sides are parallel and equal, then that quadrilateral is a parallelogram. So BD FC is a parallelogram. This implies that DF is parallel to BC. This also implies that DE is parallel to BC, right? Okay. So also we need to prove that DE is half times of BC, right? But we know that BC is equals to DF. BC is equals to DF, which is twice of DE. Okay, so since BC is twice of DE, then we can say that DE is half times of BC. Right? So what we have done is we have extended DE to F such that DE is equals to EF, and we have joined CF. And then finally we have managed to prove that this quadrilateral is a parallelogram since these two sides are parallel and these two sides are equal. So since this is a parallelogram, then BC should be equal to DF and also parallel to DF. And since DF is nothing but twice of DE, so BC is nothing but twice of DE. Okay. So then DE is half of BC. Okay. So I hope this is clear. So let us move on. Fine. So Now let us see what's the converse of midpoint theorem. Okay. Converse of midpoint theorem. So this says that if there is a triangle ABC and say D is the midpoint of AB, and if I draw a line parallel to BC through D, then this point should be the midpoint of AC, right? So it is given that D is midpoint of AB, that is AD is equals to DB. This is given, and also it is given that DE is parallel to BC. So now we need to prove that E must be the midpoint of AC, that is AE is equals to EC. Okay, so the statement is like this: through a midpoint of one of the sides of a triangle, okay, through a midpoint of one of the sides of a triangle, if we draw parallel to this base BC, then this line must pass through the midpoint of other side, that is AC. Okay, so this we need to prove. So I think you can prove this in many ways, but let us see the proof of this by contradiction method. So in this process, we'll also get to know what is the method of contradiction. Okay, fine. So now what I'm assuming is, let us assume that E is not the midpoint of AC. So I am assuming that E is not the midpoint of AC. Fine. So, and now I'll arrive at a contradiction, and then I will finally say that E has to be the midpoint because my assumption is wrong. Okay. So if E is not the midpoint, say F is the midpoint of AC. Okay. So since E is not the midpoint of AC, we can say that there is a point F which is the midpoint of AC. Okay. So let us say this is F and this is the midpoint of AC, that is AF is equals to FC. Fine. Now let us join DF. Okay, let us join DF. So we have joined DF. Okay. Now if you see this triangle ABC, okay, in this triangle ABC, D is the midpoint of AB and F is the midpoint of AC. So by the midpoint theorem, I can say that DF must be parallel to BC, right? By midpoint theorem, I can say that DF must be parallel to BC because D and F are midpoints of AB and AC. Fine. So it is also given that DE is parallel to BC, and we have proved that DF is parallel to BC. So by these two things, then I can say that DE must be parallel to DF, right? Because if A is parallel to B and B is parallel to C, then I can say that A is parallel to C. So DE must be parallel to DF, but we can see that DE and DF intersect at this point D. So these can't be parallel, right? The sides DE and DF intersect at this point D, so this can't be parallel, right? So this is a contradiction. Okay. So we have assumed that E is not the midpoint. So we have arrived at the contradiction. So then the only possibility left out is that E has to be the midpoint, right? Because if E is not the midpoint, then we are arriving at a contradiction. So E must be the midpoint of side AC, right? So this means our assumption is false. Since we have arrived at a contradiction, our assumption is false. So this implies that E must be the midpoint of AC. Okay. So this is called the method of contradiction. This is very much useful while proving some of the problems. So what do we do here in this method? We assume that the given thing is false, and then we follow some logical arguments we give, and we arrive at some contradiction. Okay. Now, since we have arrived at the contradiction, then we say that our assumption is false, and hence the contrary to our assumption should be true, right? The assumption that E is not the midpoint is false. So contrary to our assumption, that should be true. That is, E must be the midpoint of AC. Okay. So I think this is clear to you. So let us solve a question on this. So there is a triangle ABC in which D, E, and F are midpoints of AB, BC, and CA. Fine. So you need to show that triangle ABC is divided into four congruent triangles. Four congruent triangles when these midpoints are joined to each other. When D, E, F are joined to each other. Okay. So this is you need to prove. So let's try this problem. Draw the diagram and think about the problem. Then we'll discuss this. Draw the diagram and think about the problem. I hope some of you might have already solved this. So let us discuss. So it is pretty straightforward problem, nothing much involved. So we are given a triangle ABC, right? And D, E, and F are midpoints of sides AB, BC, and CA. So this is D, this is E, and this is F. So now I'm joining these DEF, right? So he is asking to prove that all these four triangles, four smaller triangles are congruent. Okay. So let us do this. Now since you can notice that D and E are midpoints of these sides BA and BC. So I can say that DE is parallel to AC by midpoint theorem, right? Similarly, I can say that DF is parallel to BC by midpoint theorem. And I can also say that EF is parallel to AB by midpoint theorem, right? So now if you look at this quadrilateral, DF is parallel to BC and EF is parallel to AB. So you can see that this quadrilateral is a parallelogram, right? So you can say that quadrilaterals DFEB, right? This quadrilateral and also this quadrilateral and this one. All these three are parallelograms. ADEF and DFECE are parallelograms. Right? Now, just consider one of the parallelogram. Say we are considering this one. Okay. So since DE is the diagonal, it divides it into congruent triangles. Right? This was the property which we have learned yesterday. So triangle DBE is congruent to triangle DEF. Fine. And similarly, if you see this parallelogram, DF is the diagonal. So triangle ADF is congruent to triangle DEF, right? So from parallelogram BDFE, since DE is diagonal, okay, then I can say the triangle BDE is congruent to triangle DFE. And similar fashion, I can prove that triangle ADF is congruent to triangle DFE, and also triangle CEF is congruent to triangle DFE. Right? Now, since all of these three triangles are congruent to triangles DFE, this means that all of the four triangles are congruent to each other. Okay. So let's move on to the next one. So here I'm given three parallel lines. So say I have parallel lines L, M, and N, and I have two transversals cutting these three parallel lines. So this is transversal P and this is transversal Q. Okay, so this cuts the parallel lines at ABC and this cuts at DEF. Fine. So now it is given that B is the midpoint of AC, that is AB is equals to BC. This is given. Right? So you need to prove that DE is equals to EF. Right? So AB is equals to BC is given. You need to prove that DE is equals to EF. So try this problem for a minute, then we'll discuss. So LM and are three parallel lines, and there are two transversals P and Q. So the transversal P cuts off equal intercepts. Equal intercept means AB is equals to BC. So you need to prove that Q also cuts off equal intercepts. That is DE is equals to EF. Okay, so let me give you a hint. So the hint is that you just join AF. If you join AF, then the things will be clear how to do this. Okay. So I'll give 1 more minute and then we'll discuss. Fine, so let us discuss. So let us join AF. Okay. So if I join this AF, let us say AF meets the line M at some point P. Fine. Now you consider this triangle, that is the triangle ACF. Okay. So in this triangle, B is the midpoint of AC and BP is parallel to the side CF, right? So since B is the midpoint of AC and BP is parallel to CF, then P must be the midpoint of AF, right? This is by the converse of midpoint theorem. Okay. So from triangle ACF, I can say that AB is equals to BC and BP parallel to CF. This implies that AP must be equal to PF. Okay. So now let us consider this triangle, that is the triangle ADF. So in this triangle ADF, we have already proved that P is the midpoint of AF, that is AP is equals to PF, and we know that PE is parallel to AD. So if P is the midpoint of AF and PE is parallel to AD, then E must be the midpoint of DF by the converse of midpoint theorem. So in triangle ADF, I can say that AP is equal to PF and PE is parallel to AD. So by these two things, I can say that DE must be equal to EF. And so I have proved. Okay, so I hope this is clear. Let's move on to the next question. So you are given that AD and BE are medians in a triangle. And F is a point F is a point on AC such that DF is parallel to BE. Right? So F is a point on AC such that DF is parallel to AE. And it is given that AC is equals to 8 centimeters. So you need to find out the value of CF. Okay. So draw the diagram and think about the problem. And if you get the answer, let me know it in the chat. It's a pretty simple problem, just the application of converse of midpoint theorem. Okay, so let us discuss the problem. So there is a triangle ABC and AD and BE are the medians. So AD is the median and BE is the median. Fine. So then BD must be equal to DC, right? And it is given that F is a point on AC such that DF is parallel to BE. So say this is a point F such that DF and BE are parallel. Now it is given the value of AC as 8 centimeters. We are asked to find out the value of CF. Okay. So if we consider the triangle BEC, right? If you notice this triangle BEC, D is the midpoint of this side BC and DF is parallel to BE, right? So D is the midpoint and these two are parallel. This means that F must also be the midpoint of EC, right? So from triangle BEC, since D is midpoint of BC and DF is parallel to BE, then I can say that F is the midpoint of EC, right? So this implies that EF is equals to FC. And also we know that since E is the midpoint of AC, I can say that AE is equals to EC. So by these two relations, you can say that FC is nothing but 1/4 of AC, right? So it is nothing but 2 centimeters. Okay. So I hope this is clear. So let us just quickly recap what we have learned till this point. So first we have learned what is midpoint theorem. So if in any triangle ABC, there are 2 points D and E on AB and AC respectively, such that D and E are midpoints of AB and AC, then this line DE, if joined, this will be parallel to BC and half of BC, right? So if D and E are midpoints of AB and AC, then DE is parallel to BC and it is half of BC. And the converse of it says that if you take a midpoint of AB, right? If I take a midpoint of AB, say D, and I draw a line which is parallel to BC, then this line will definitely pass to the midpoint of side AC. Right? This is the converse of midpoint theorem. So now let us see a very interesting application of this theorem. So we know that the medians of a triangle are concurrent, right? So now we'll prove that they are concurrent. Okay. So we will prove that medians of a triangle are concurrent. So this is our task. Okay, so let us consider triangle ABC. So what do you mean by medians are concurrent? It means that all the medians pass through the same point. So what I'm doing is I'm drawing the medians through B and C. So let us say that BE and CF are the medians. Okay, so this is given. Let us say these two medians intersect at point G. Okay. Now, okay, I can join AG, right? I can join AG and I can extend this. This thing I can do it. Now let us say this meets side BC at D. Okay. So what I'm doing is I'm joining AG and producing it to cut BC at D. Okay, this is what I have done. So I have assumed that BE and CF are medians. So I have assumed that AE is equals to EC and AF is equals to BF. This is what I have assumed. Okay. Now the point of intersection of BE and CF, I'm taking it as G. Fine. Now I'm joining AG and extending it to cut BC at D. Okay. So now my task is to prove that BD is equals to DC. Right? This is my task. If I can prove that BD is equals to DC, then I have proved that medians are concurrent. Okay. So let me repeat it again for you. We have taken that BE and CF are the medians. Okay. Now two medians can definitely intersect at point G. Now I'm joining AG and extending it to cut BC at D. Okay. So now AD may not be median, right? It may not be median, but we know that the medians are concurrent. So AD has to be the median. Okay. So we have to prove that AD is the median. So to prove AD is the median, we have to prove that BD is equals to DC. Okay. So I hope you understood the problem statement clearly. Okay. So now what I'm doing is I'm further extending this GD to a point K such that AG is equals to GK. Okay. So I am extending GD to K such that AG is equals to GK. Fine. And now I'm joining these two things. That is, I'm joining KC and I'm joining BK. Okay. So what I have done, I have extended GD to K such that AG is equals to GK, and I have joined BK and CK. Okay. Now let us observe this triangle ABK. Okay. We are observing the triangle ABK. You can see that in this triangle ABK, F is the midpoint of the side AB and G is the midpoint of side AK, because we have constructed this in such a way that AG is equals to GK, right? So in triangle ABK, just a second, in triangle ABK, I know that F is the midpoint and G is the midpoint, then FG should be parallel to BK, right? FG should be parallel to BK, and also FG should be half of BK. Okay. So what we have observed is that FG is parallel to BK and FG is half of BK, right? This is what we have observed from the midpoint theorem in triangle ABK. Okay. So similarly, let us consider this triangle AKC. Okay. Now in this triangle AKC, E is the midpoint of AC and G is the midpoint of AK. So I can say that GE must be parallel to KC and GE must be half of KC. Fine. So also from triangle AKC, I can say that GE is parallel to KC and GE is half of KC. Fine. This is what we have observed from triangle AKC. Okay. So let us analyze these two things. That is, FG is parallel to BK and GE is parallel to KC. Okay. So since FG is parallel to BK, I can say that GC is parallel to BK, right? Because FGC is a straight line, right? So I can say that GC is parallel to BK. Similarly, since GE is parallel to KC, I can say that BG is parallel to KC because BGE is an entire straight line. So if GE is parallel to KC, then BG is also parallel to KC. Okay. So from this I can say that GC is parallel to BK, and from this I can say that BG is parallel to KC, right? So now if you see this quadrilateral BGCK, we have proved that BG and KC are parallel, and we have proved that GC and BK are parallel. So if both pairs of opposite sides are parallel, then this quadrilateral is a parallelogram, right? So from these two things, I can say that BGCK is a parallelogram. Okay. Now since BGCK is a parallelogram, this implies that diagonals bisect each other, right? Diagonals bisect each other. So this implies that BD must be equal to DC. Okay. So we have proved that BD and DC must be equal. So that is, we have proved that AD is a median of the triangle ABC. So let us just do it again. So there was a triangle ABC. We need to prove that medians are concurrent. We have assumed that BE and CF are the medians intersecting at point G. Now I have joined this AG and extended it to K such that AG is equals to GK, right? And this cuts the side BC at point D. And by a series of arguments, I have proved that BD is equals to DC. That means that AD is also the median, right? So this median AD must definitely pass through point G. So I have proved that if BE and CF are medians, then the median AD must also pass through the point of intersection of BE and CF. That is the point G. So I have proved that the medians in a triangle are concurrent. Okay, now let us also see the ratio in which the centroid divides the medians. Okay, so since the diagonals bisect each other, I can say that BD is equals to DC, and also I can say that GD is equals to DK, right? Because in this parallelogram BGCK, diagonals are BC and GK, right? So BD is equals to DC and GD is equals to DK. Okay. Now since GD is equals to DK and AG is equals to GK, so I can say that AG is nothing but twice of GD, right? So then I can say that AG by GD is nothing but 2:1. Fine. So my AG by GD is 2:1. And in a similar way, I can say that BG by GE must be 2:1 and CG by GF must be 2:1. Fine. So similarly, I can say that BG is to GE must be 2:1 and CG is to GF must be 2:1. So what we have proved that in a triangle, the medians are concurrent, and the point of concurrence of these medians, that is the centroid of the triangle, this divides each median in the ratio 2:1. This is what we have managed to prove. Okay. So let me leave you with a task. The task is that you need to prove that these smaller triangles, right? There are 6 smaller triangles here. Okay. So the triangle BGD, GDC, all these 6 smaller triangles are equal in areas. Fine. So each of the area of triangle BGD, GDC, right? All these areas are equal to 1/6 of area of triangle ABC. This is what you can try at home. Okay. So let's move on. Let us discuss a simple problem. So there is a triangle ABC given to me, and it is given that BE is perpendicular to AC. So this is BE, this is perpendicular to AC, this is given to me, and AD is any line from A to BC intersecting BD, intersecting BE in H. So AD is a line from A to BC intersecting BE at point H. Okay, and PQR are midpoints of AH, AB, and BC. So PQR are midpoints of AH, AB, and BC. Right? So you need to prove that angle PQR is equal to 90 degrees. Okay. So it is given that BE is perpendicular to AC and PQR are midpoints of AH, AB, and BC. You need to prove that angle PQR is 90 degrees. So try to draw the rest of the diagram and think about the problem. So complete the diagram and then think about the problem. We'll discuss this in a couple of minutes. Okay, so D is any point on BC. Fine. One of you has asked what is AD. So D is any point on BC and AD intersects BE at H. Fine, so let us discuss this problem. So it is given that PQR are midpoints of AH, AB and BC. So the midpoint of AH is P, the midpoint of AB is Q, and the midpoint of BC is R. Fine, we need to prove that angle PQR is 90 degrees. So let us join this QP and QR. Okay, just a second. So I need to prove that this angle PQR is 90 degrees. Fine. So let us consider this triangle ABH. Right? If you consider this triangle ABH, Q and P are midpoints of AB and AH. So QP must be parallel to PH. So from triangle ABH, since Q and P are midpoints of AB and AH, then I can say that QP must be parallel to BH, right? Now similarly, I can say that QR is parallel to AC, right? Because Q and R are midpoints of the sides CA and AB. So QR must be parallel to AC. This is what we can observe from triangle ABC, right? So from triangle ABC, I can say that QR is parallel to AC. Okay. So now this just by observation, we can say that this angle is 90 degrees. Let us see how. So AC is parallel to QR, right? AC is parallel to QR, and BE is parallel to QP, right? Because BH was parallel to QP, this means that BE is parallel to QP, right? So if the angle between this line and this line is 90, then angle between this line and this line must be 90, right? So angle between AC and BE is 90 degrees. Then the angle between a line which is parallel to AC and another line which is parallel to BE must also be 90 degrees, right? So this is sufficient to prove that angle PQR is nothing but 90 degrees. Fine. So now let us look at what is a basic proportionality theorem in a triangle. So this is also known as Thales theorem. So it's similar to midpoint theorem. You can also say that midpoint theorem is a special case of basic proportionality theorem. So what this theorem says is that if there is a triangle ABC and if you draw any line parallel to BC which cuts AB at D and AC at E, right? So we have drawn any line DE which is parallel to BC. So it says that this parallel line DE divides AB and AC in the same ratios, fine? So any parallel line DE to BC divides AB and AC in the same ratio. This means that AD by DB is equal to AE by EC. Fine. So this is what we need to prove. Okay, and it is given that DE is parallel to BC. This is given, and this is what we need to prove, that this line DE divides AB and AC in the same ratio, that is AD by DB is same as AE by EC. Okay, so let us prove this. So what I'm doing is I'm joining this BE and CD, and now I'm going to use the ratio and proportion lemma or the area lemma, which we have learned in one of our previous sessions. I can write AD by DB. Okay, if you see AD by DB, I can write this as area of triangle EAB upon area of triangle EBD, right? Because the height from E to both the triangles ADB, ADE and EDB is same, right? The height from E to this triangle ADE is same as the height from E to triangle ABD, right? So this height is same for both the triangles. Then I can say that AD by DB is nothing but area of triangle AED upon area of triangle BED. Okay. So you can also check this by just dropping a perpendicular from E to AD. Say this is M, right? So area of AED is what? Half times AD times EM, right? This is half times AD times EM, and area of BED is half times BD times EM. So EM and half gets cancelled, and you are left with AD upon DB. Okay. So now let us write for AE upon EC, right? So AE upon EC, okay, using the same lemma, I can say that AE upon EC is same as the area of ADE upon area of CED. Okay, so this is area of AED upon area of CED, because the height is same for both the triangles AED and CED. That is the perpendicular distance from D to the line EC. This is the height for this triangle as well as for this triangle CED, right? So I have wrote this. Now I need to prove that AD by DB is AE by EC. If you look at the right hand sides of both the equations, you can see that numerator is same, right? That is AED is same as AED, but the denominators are different, right? So somehow if I can prove that these two denominators are equal, then my task is done, right? Then I have proved that AD by DB is AE by EC. So let us try to prove that these two quantities are equal. That is, the area of triangle BED is same as the area of triangle CED. This is what we need to prove, right? Okay. But if you see these triangles DEB and triangle DEC, you can notice that these two triangles are on the same base DE, and these are between the same parallel lines, right? So since these two triangles are on the same base DE and between the same parallel lines, because it was given that DE is parallel to BC, so the area of these two triangles is anyways equal. So the area of triangle DEB is same as the area of triangle DEC, because triangles are on same base and between the same parallel lines. So if these two quantities are equal, that is BED and CED are equal, then the right hand side of these two equations are equal, then left hand sides must also be equal. So then I have proved that AD over DB is same as AE over EC. We have proved this. Okay. So if in any triangle DE is parallel to BC, then this divides AB and AC in the same ratio. That is, AD over DB is same as AE over EC. So this is known as the Thales theorem. Okay. So now let us look at the converse of this also. Converse of the basic proportionality theorem. So what this one says is that if you have a triangle ABC and say there is a side DE. Okay, so if you are given that AD over DB is same as AE over EC, right? If you are given that AD over DB is same as AE over EC, then you can say that DE is parallel to BC. Okay, so this is the converse of this theorem. So you can try this at your home by the similar method of contradiction which you have used to prove the converse of midpoint theorem. Fine. Let us also look alternate ways to write this. Okay, so if AD by DB is equals to AE by EC, right, then also I can write AD by AB is equals to AE by AC. Fine. That is AD over AB is same as AE over AC. This you can get by adding 1 to both sides of this equation, right? If you add 1 to both sides of this equation, then you will get this one. Similarly, you can also write that BD over BA is same as CE over CA. There are so many ways to express this. BD over DA, BD over BA is same as CE over CA. This you can get by reciprocating this equation and then adding 1. Okay, so you should maintain uniformity in writing, right, on both the sides. That is BD over BA, you write it as CE over CA. So AD over DB, you write it as AE over EC. If there is BD over DA, you write it as CE over EA. If there is AD over AB, you write it as AE over AC. So just different ways of writing the basic proportionality theorem. So all are similar. Okay. So now let us solve the question on this basic proportionality theorem. So let us say we are given 3 parallel lines L, M and N. Fine. And say there are 2 transversals P and Q. Okay, so this cuts LMN at ABC and this one cuts at DEF. Fine. So it is given that AB over BC. So I mean you need to prove that AB over BC is same as DE over EF. So in the midpoint theorem we have solved a similar type of example. Just think about this problem. So you need to prove that AB over BC is same as DE over EF. So let's try this problem for a couple of minutes, then we'll discuss. Yeah, so let's discuss this problem. So by the same logic which we have used for a similar example in the midpoint theorem, let us join AF. Okay, so we have joined AF. Let us say this point is P. Okay, so now you can see that from triangle ACF, since BP is parallel to CF, right? In triangle ACF, BP is parallel to CF, then I can say that AB over BC is same as AP over PF. So from triangle ACF, since BP is parallel to CF, I can say that AB over BC is same as AP over PF. Right? Now you consider this triangle, that is the ADF1. So from triangle ADF, you can notice that DE over EF is same as AP over PF, right? Because PE is parallel to AD, right? So in triangle ADF, PE is parallel to AD, so DE over EF is same as AP over PF, since PE is parallel to AD. So if you combine these two equations, then you can directly say that AB over BC must be equal to DE over EF. Okay. So I hope this is clear. So we'll end the today's session and I'll send you the assignment in the group. And if you have any queries, then you can message.